Okay, section 2.1, problem number 9 is a really good problem. I'm glad this one was asked, and there's a lot going on within this one. So let's take a look. We've been given a figure right here. We're supposed to focus on the red kind of curve on that graph right there. And I don't know, I'm assuming this information is accurate. They didn't just make this up. Figure 9 shows the estimated percentage P of the Chilean population that uses the internet. Okay, cool. Based on data from the United Nations Statistics Division. Good for them. All right, we're asked to use this now to come up with a few things. So 4 different questions here. Part A, estimate the rate of change of P, that's the function we were given right here, P at t equals 2010. Okay, now one thing we want to make sure we talk about here, when they use the phrase estimate the rate of change, it is implied that the word my pen doesn't work well here, but instantaneous OUS, is the type of rate of change they're trying to get us to find here. If they ever want us to find an average rate of change, they will use the word average. So if they just say rate of change, that means instantaneous. And one of the big takeaways here from this section is that an instantaneous rate of change, and in this case right here at this dot at 2010, is the slope of the tangent line to the curve at that particular point. Okay, so that's essentially what they're asking us to do here in part A. They want us to come up with the slope of the tangent line to this curve at t equals 2010. And they were nice enough to draw that tangent line in for us. That's what that dotted black line is for. So our job is to come up with the slope of that dotted black line. Now, how are we going to do that? For 5 or 6 years, you guys have been taught that you can find the slope of a line using 2 points. The problem here is with a tangent line, there's only 1 point that's given to you. And furthermore, the position of that 1 point right there is messy. I know that that blue dot has a t value or an x value of 2010, but in terms of its y value, the percentage of the Chilean population using the internet at that time, this is a guess right here. Between 35 and 50, it's closer to 50, so I would guess maybe it's 45%, but I don't feel all that confident about that number right there. So what we're going to do instead, guys, is ignore that point, again, because the line is already drawn for us, and we're going to try to find 2 clean points on that line. What I mean by that is 2 points that have coordinates that are pretty close to being integers or numbers that I feel pretty confident in. And I think I can read pretty clearly that this point right here is 2008 and then 35% for our y value. And it looks like there's another pretty clean point right over there where our t value is 2011, and at that point it looks like 50% of our Chilean friends are using the internet at that time. So using those 2 points, here we go, guys. Slope of the tangent up here on the top is change in y over change in x. F of b, my ending y value, which is at this point right here, is going to be 50%, minus f of a, my starting y value right here, is 35%. And then down on the bottom, the change in x, or in this case, the change in t, the ending t value is at 2011, minus right here, the starting t value is at 2008. Now, we can go ahead and solve this pretty quickly, but I do want to talk about what it is we've accomplished. 50 minus 35 is obviously 15, and down on the bottom from 2011 to 28, we have had 3 years go by, so we end up with an answer here of 5. Congratulations, you got it. Bad news, though, you have no idea what you've accomplished until we talk about it. So let's think about units. Up on the top, the 50 and the 35, those were percentages. So what that 15 means is that we've had 15% growth here in Chile in the percent of our population that is using the internet. Over how long of a period of time? 2011 and 2018 were years. So over a period of 3 years, our percentage of our population using the internet went up by 15%. So what we actually found right here is an average growth of 5% per year. So it didn't exactly work like clockwork, but roughly, on average, another 5% of our population started using the internet each year from 2008 to 2011. Okay, let's get into the rest of this now, guys. So that's part A, and let me try to erase some of the junk that I put on this graph here before, and let's take a look at part B. Does the rate of change increase or decrease as t increases? And we're supposed to explain graphically. Now again, they're just using the phrase rate of change, which again means we're talking about an instantaneous rate. And what that means, everybody, is the slope of a tangent line. Now, what I think you can see from the graph, as well as from common sense, this red graph is strictly increasing. The percent of Chileans using the internet is never going down according to this model. But the question is it increasing at a constant rate? Is it increasing at a decreasing rate, or is it increasing at an increasing rate? So what I would probably do is try to draw the tangent line to this curve at maybe 3 different points. One right here, I'd guess maybe it looks like that. We had that dotted black one already, okay, so that's a second tangent line, and a third one looks like it might look like this. Now, if you compare those 3 tangent lines, the question is, as we move from left to right, is the slope of those 3 tangent lines staying the same, or getting steeper, or getting less steep? Well, as I think you can see, the tangent line that I've drawn on the right here in blue is the steepest out of the 3. The one on the left is the least steep, or the shallowest, and then of course the one in the middle is kind of in the middle. It would appear that that line is getting steeper, and so that tells us that our rate of change of people using the internet here over time, it increases. And the reason I would write, I'll let you guys do this on your own, is because the tangent lines get steeper as we move, boy, that's awful, as we move from left to right. Okay, so I'm going to erase all of this, and let's move on now to part C. Let R be the average rate of change of the interval from 2008 to 2012. Compute R. I wish they'd started you guys with this question. Okay, here they're asking for an average rate of change, and unlike an instantaneous rate of change, where they ask you to do that at just one time value, an average rate of change requires an interval, 2 time values. So we've got to focus on what's going on right here in the year 2008 and then right over here in the year 2012. And unfortunately, this is going to require us to take some guesses. Our y values at those 2 points are anybody's guess. I would say that this one over here on the left, I'm going to just take a stab in the dark here, guys, and say that it's 39. You might have guessed 38 or you might have guessed 40. I don't really care. As long as you explain in your paper what it is that you chose, good enough. This y value right over here, that one I'm going to go, I don't know, 56. We'll run with that. And so now for part C, we've got a formula here, guys, for average rate of change. I guess you could use don't use your calculator here because you don't know what f of x is. The function isn't defined. Change in y. We end at 56% minus the starting y value. We started at 39%. And the change in x, we ended in the year 2012 minus 2008. So what does that do for us? Over this interval here, we saw 17% growth in our internet use among our population over a 4-year period. So using this numbers then, you would divide that out, and I came up with that would be 4 1/4 or 4.25. And again, that would be percent per year. So that's the average amount of growth that we came up with on this interval here from 2008 to 2012. You'll notice that's in the vicinity of this answer we came up with right here in part A, but not exactly the same. That's not surprising. Okay, and then the last part of this question here, part D, is the rate of change. Now again, it just says rate of change, so we're going to use that as an instantaneous rate of change, guys, is the instantaneous rate of change at 2012, and we would model that with the slope of your tangent line right here at that point. Is that rate of change greater than or less than the average rate of change R? Ooh, now that's what we just came up with in part C, so I shouldn't have erased that. Let me go back to where we were a second ago. The average rate of change in part C started here, ended here. And what we found in part C, an average rate of change, remember guys, that's the same as the slope of a secant line measured between these 2 points. So I'm going to just eyeball this secant line right here. I'll try to draw that in green. Okay, and that's what we have there, a secant line from 2008 to 2012 in green, but then, had this a second ago here, the tangent line we have drawn right here is in blue. Just at 2012, we're not using any other data point to determine the slope of a tangent line. So the question is about whether the rate of change here is greater or less. We're talking about slopes, everybody. So the question is the slope of the tangent line in blue greater than, less than, or equal to the slope of the secant line in green? And as I think you can see from that graph right there, that blue tangent line is steeper than the secant line. So we would say here that the instantaneous rate of change at t equals 2012 is, all right, a steeper line means that it's increasing faster. So we would say that that instantaneous rate of change is greater than the average rate of change on the interval here from, sorry guys, let me, that's about to get ugly. Let me move all that up a little bit. There we go. All right, is greater than the average rate of change measured on the interval here from 2008 to 2012. And now I see there's another question that was asked right here. What about the rate at 2008? So again, 2008 is just a single data point. They're asking us for an instantaneous rate of change here, and I would guess that that one looks maybe something like that. I would still say that the 2012 rate of change is greater than the instantaneous rate of change was at 2008. Although now that I've zoomed out on that, it's a little bit harder to see. I suppose if I really wanted to get this right, I'd probably go back and erase a lot of this junk and maybe redraw those two tangent lines just at those 2 points. So at 2008, maybe something like that, and at 2012, maybe something like that. Yeah, I would still say that 2012 tangent line is steeper than the 2008 tangent line, but it really is a guess here, guys, when they're asking us just to come up with something like that. So, okay, that's a wrap on problem number 9, everybody, in section 2.1.